In this video, I'm going to show you what is probably one of the most advanced AI features in QDA Miner, a feature that allows you to analyze response to open-ended survey questions very quickly. For this demonstration, I'll be using a survey dataset of 969 respondents, all gamers, who answered the question, "Do you develop any real-life skills while playing online games?" Let's start by switching to the QDA Miner grid mode view, which is much more convenient for analyzing open-ended questions. As you can see, there are no code yet in the coding window in the lower left corner. So of course, I could create code manually, apply them to each responses one by one. I could also perform text search or use the cluster retrieval encoding features to quickly code those responses. But instead, I'm going to use QDA Miner new generative AI features, which will automatically generate a codebook and apply it to the response. To access this feature, go to the Analyze menu, select AI Analysis Scripts, and then choose the Open-Ended Analysis Encoding command. The first option in this dialog box allows you to select the text variable in your datasets that contain the question you want to analyze. If your survey has more than one open-ended question, you can adjust this option to select the one you want to code. Just below, there's an edit box where you can give the AI some context about the response it will receive. If these are answers to open-ended questions, it is best to specify the exact question that generates the responses, and also include any contextual information that might help the AI understand the purpose of the question. In my example, I simply wrote that these are responses to an open-ended question, and I included the question, "Do you develop any real-life skills while playing online games?" I didn't think that adding that the respondents were gamers added much useful context here. Below this edit box, I need to choose whether I want the AI to create a brand new codebook for me or use an existing one. Since I don't currently have any code, the most practical choice right now is to let the AI generate a codebook. There are, however, many situations where using an existing codebook makes more sense. For example, if I'm working on a tracking survey, I'd want to apply the same set of code so I can compare current results with past ones directly. I may also already have a clear idea of the categories I need because I'm testing specific hypotheses, working towards a research goal, or following a client requirement. In that case, we're using the same codebook ensure coding consistency across all responses. That's where the uncoded document-only option at the top becomes relevant, because I don't want the AI engine to recode responses that have already been coded. There's also an option to include the code description. This is especially useful when the code's names aren't self-descriptive enough or when specific nuances need to be made. The code description may specify conditions for using a code or some example. Now let's see what happens when I ask the AI to generate a codebook for us. When I click OK, I get another dialog box where I can choose which AI engine to use, which model, what temperature settings I want. Temperature is a numeric option to control how predictable the AI output will be. A low value like 0.1 will generally be more stable and reduce the chance of hallucination, while a higher value like 1.0 will produce more creative response, often at the cost of stability. For this example, I will select OpenAI as the engine, set the model to GPT 4.1 mini, and I will keep the temperature at 0.1, which is the good setting for coding open-ended response. When I click OK, QDA Miner will gather all the response and send them to the AI engine asking it to propose a codebook. This usually takes just a few seconds and return a dialog box displaying the proposed codebook. Let's see what we get. Generative AI can sometimes produce inconsistent results, and the proposed codebook may not always be what you're looking for. For example, there may be too many or too few codes, or the codes may be irrelevant. In such case, you have two options. If the codebook is way off, you can click the retry button to get a new suggestion. Let's do this. You can do this repeatedly, and you can move back and forth between different proposals to choose the one that fits your need. The second option is to manually edit the proposed codebook. The three buttons in the upper left corner allowing you to create a new code, rename a code, and edit its description, or delete a code. You can also access this function by right-clicking a code. There are no dedicated merge or split button here, but you can still achieve those by combining the add, delete, and rename function. Once you're satisfied with the displayed codebook, click Apply to have the selected AI engine code all the response using it. Alternatively, you may also append the proposed codebook to your current one by clicking Save and exiting, allowing you to apply it later either manually or automatically. Let's go ahead with AI coding. QDA Miner will split the full set of response into smaller chunks. We do this for several reasons. The main one is to avoid timeout that can happen if a task takes too long. Another is that even though many AI engines can process large documents, we found they perform better and are more reliable with smaller batches. Finally, breaking the task into chunks let QDA Miner shows a progress bar, estimate the total processing time, as well as allow you to interrupt the analysis if needed. The current estimate says it'll take a couple of minutes to quote all response, so I'll speed up the video here and skip to the results. The coding preview dialog box lets you review the AI suggested coding before applying it. Just like with the proposed codebook, QDA Miner will give you a chance to check and modify the proposed coding before it's finalized. Let me resize a few elements so we can see everything clearly. On the left, you can see the codebook that has been applied to the survey responses. It often includes a few additional codes, like here, another, and a no response code. Next to each code is the number of time it was applied and the percentage of case in which it appears. On the right, there's a table with 3 columns: the case number, the survey response, and the assigned code. Now let's focus on the codebook panel. As you can see, it has some of the same editing tool as before to add, delete, or edit a code. But we also have an additional merge button. This lets you merge a less used specific code into a broader one. You may also use it to combine several low-frequency code into a other category. To merge a code, select the code you want to remove, click the merge button, and choose from this list the code you want its item reassigned to. You can also merge an entire category into a single code. This will delete all codes underneath and reassign their item to the newly created code. The bar chart button at the top allows you to easily create a graph to represent the frequency or the percentage of codes. You can choose to display the results in a vertical bar chart, a horizontal one, using a pie chart, a donut chart, or a word cloud. All charts can be fully customized and can be saved to disk or copied to the clipboard. We implemented several features to make it easier to review AI coding. Let's look at some of those. The table on the right shows all the response in their code. Clicking the funnel button filters the response to only show those with the selected code, allowing you to focus revision on a specific one. If a code doesn't belong, you can select the row, right-click, choose Remove, and select the coding to delete. And if you believe a code is missing, you can simply right-click, choose Add, and pick it from the list like this. Another method to modify the coding is to push down the checkbox button. Doing this, add checkbox next to all codes, so you can add or remove them from the selected response with a simple mouse click. Let me show you. Let's select this response. Now I will remove this code, and I will also add this one. By the way, none of these coding have been saved. To save those, you need to click the Apply button. We'll do that later. But first, let's talk about another important feature. We all know that generative AI is not totally reliable, and that it may provide different results even when it has to perform the exact same task. Such a shortcoming is not unique to AI and has long been documented when using humans to code text response. Even a single user may often not code the same way the same datasets when has to do it at different times. One well-known solution to address a coding reliability problem with human code is to perform intercoder's agreement assessment. It consists of having two persons coding the same response independently and comparing the results. This allows the researcher to identify distinctions that may be more difficult to perform, as well as items that are hard to classify. One may also code the same data twice at different times and compare the coding performed at those different times. QDA Miner allows you to perform a similar procedure by running the coding operation multiple times using either the same model or by varying those, and then comparing the results to assess the coding stability and reliability. To perform such a task, click the AI button and select the stability testing command. When you do this, you will be asked to select the AI engine and model to use. In this example, we will use the same model used initially, so let's click OK. Once the second round coding is complete, you'll get a dialog box with two tables like this one. The first table on the left shows for each code how often it appears in both runs, how often they disagree, and the percentage of agreement. There's also an overall agreement score at the top. The second table highlights codes that may be confused with each other. Codes with low agreement score may need to be reviewed closely, merged, or refined. Codes with high percentage agreement or 100% agreement are likely much clearer and unambiguous and may not need as much attention. If we close this dialog box and return to the main coding review interface, we can see if in the last column of the response table exactly where disagreement occurred. An empty cell indicates full agreement. The same codes were applied in both analyses. If a code from the original analysis is absent in a stability run, it will appear with a prefix missing. On the contrary, if a code appears in a stability run but was not in the original coding, it will be shown with the prefix extra. Focusing on those non-empty cells allows you to efficiently review responses that are more likely to contain discrepancy or potential error. You can repeat this test multiple times, experimenting with different engines or models, and potentially find the most reliable approach for your kind of data. Finally, when you're done reviewing, click the Apply button. The entire codebook have just been applied to my existing codebook. Notice that QDA Miner automatically assigns different colors based on the categories. It also went through the entire set of response, applying the final code assigned by the AI coding features and reviewed by the users. In this video, I spent extra time explaining each feature and running additional analysis. But if you just want a quick overview, or if you trust the AI reliability enough to skip manual review, it is significant to mention that the whole process, including the codebook generation and the coding, took less than 3 minutes. And the cost for coding those responses using GPT 4.1 mini was just 4 cents. Even the more expensive GPT 4.1 would have cost only 12 cents. Generative AI may one day fully replace human coders for tasks like coding open-ended responses, but we are not quite there yet. That's why QDA Miner gives you the opportunity to review and interact with the results at several points during the analysis. This way, you can refine the output, correct any inconsistency, and ensure the final coding meets your standard. Still, when used under the guidance of a human expert, generative AI already offers significant time saving and makes the coding process faster, more consistent, and more scalable.